In this video, I'd like to show all you guys how I make these coils. I'll show you how well they work in some other videos, but primarily in this video, I'd like to try to show you how to make the cores that go up through the center of these coils. And these are the different types of cores. The materials that I use to build those cores, which are these little RF chokes, and originally they have wires around them. I just stripped the wires off and cleaned the glue off. And this is an RF choke also. I cut them because they're in a U shape. I buy them off of eBay, and once you cut them, then you can stack them just like you do these. Now I found out in building these cores that the round ones work better than the square ones. Now, even though the square ones are bigger and these are smaller, I think primarily the difference between the two is the type of what they use to make these, the frequency of these cores, and these cores are primarily designed to cut out to use as an RF filter to cut noise out of circuits. So that's why these work good. Now, in this video, I'm going to show you how I make this core. This is just one that I've made to demonstrate basically how I make these cores and the composition of what I put inside these cores. Also, I'm going to try to attempt to show you how I wind these cores. So I made this little board to show you how I wind them, because I find that how you wind this is a very critical element in whether this works or not. So this is one of the cores, one of my early first cores. It's too small now, but I just built it to test the theories to see if they would work, and they did. So anyway, I've built quite a few of these cores. Some of them have square centers in them like this one. Some of them have round centers in them like this one. This one here, I put 3 of those in, and I built it up through and built a longer core, and then I wound wires around it. But the winding is a Rodin winding. It's how you build Rodin. There's what they call star coils. And what that does is it concentrates the magnetic field in the center. And if you wind it right, you can really take advantage of how these how the cores are wound. Now, when I wind these cores, it's very important. Now I put 12. I just bought these wooden pegs at Hobby Lobby. They're just wooden pegs, and they come about a foot long. And I cut them down to whatever size that I need. So if I'm building a core, say for example this core, I build them up to just below the top of the surface because the windings always have a tendency to come down. So that's what I'm going to demonstrate. Now, when you're winding these cores, and I use 24 gauge. So 24 gauge seems to be it works really well. It handles the current, and it also keeps the resistance high enough to where you get a lower current to drive the coil. Now, I've tried building these out of 26 gauge. It works well, but the magnetic field is not strong enough. I've tried building it out of 22 gauge. It also works well, but it draws a lot more current. 24 gauge seems to be the ideal wire thickness to build these cores. I'm not sure exactly why, but it just seems to be a good balance. Now, on the center cores that I build, this is basically to take off power. On the center cores, I was running the same gauge. I was running 24 gauge, and I switched it to 22 gauge. And you can really get a lot of output from this. And I find that you don't necessarily have to have a lot of windings In fact, it's more efficient if you don't put as many windings on this core. It just happens to work well that way. So now I need to show you how to wind these cores once you've got them built. And the most important thing is you go straight across from wherever you're at. You go straight across. So if you're from here, you go. If you're from here, you go to here. From here, you go straight across, which is this one. From here, you go straight across, which is this one. So what you do is you go straight across like that, straight across, and then you go over one like that. And then you turn it around and you do the same thing. You go straight across, which is from here to here, and then what you do is you go over one. And you do the same thing. You go straight across, which is from here to here, and you go over one. And you keep doing that until you build the coil. But there isn't a very important step that I haven't shown before, and I'm going to show it now. Once you get all 12 of these loaded up with one winding, and it's very important that you do this. And this also makes or breaks whether it works or not. But once you get one winding on this thing, like this is how I do it. And once you get one winding on it, what you do, or what I do, that completes one turn on each one of the posts, the 12 posts. I usually make a circle or go around it once, make a loop, go around it once, tie it down. And this is very important. You can't just keep going around like that. What you have to do is you have to keep going to the clockwise or counterclockwise, whichever way you decide to wind it. But what you do, and what I do, is you have to go all the way around the core. And you can go all the way around the core, and you just go all the way around it. You know, I keep it down as low as you can keep it. And remember, we started with this one, so you go all the way around. And then what you do is I go, instead of going one over, I go two over. And then I go 12 times. I count 12 times. So I go across this one, and then I go two, and then I go 3, 4, 5, 6, 7, 8, 9, 10, 11, and then this makes 12. And what I do is I'll loop it around again, and then I'll push all of this down as close as I can get it. Now sometimes it helps if you take a pair of pliers or something, anything, doesn't matter, go up like this between the windings, and that compresses them in on the core, and it makes it look neater, and it actually helps helps a lot in how the results and how it turns out. And then usually what I'll do is I'll squeeze these ends together. That makes the wires tight. And now you do that on the first few windings. You don't want to do it up as you get higher, because what it'll do is it'll cause your pegs to bend in if you get them too tight. And then once you've got that one done, then you do the same thing. You go around it. Now here's where I'm at. This is the one, and I go over to here. So that would, if you look at it, I'm skipping 2 over. So I go all the way around it. Keep this down as close as you can keep it down. and then I skip 2 over, like so, and then I go, again, I go 12 again, and that's 2. Sometimes they get mixed up on my counting, but it's not critical. I mean, the main idea is you get a fairly even wrap around this core. So, like, say if you lose track and you say, well, that was 3. Was it 3 or whether it's 4? Well, you know what? I'll call it 4. It doesn't matter. So 4, 5, 6, 7, 8, 9, 10, 11, and then 12. And I'll make a loop, and I'll push this down as far as it'll go. I'll push these in, get them where they're snug up against the center, the core, like so. And then now this works well. Now I find that it depends on the core what works the best. If you just got one center, and then you skip over 1. If you got 2 or 3 centers, you skip over 2. It puts more actual wire around the core. It compensates for the density of your center core. So what I mean by that is, okay, instead of going 2 over, we'll go 1 over. So I'll go here, around, like so, and then keep it down as close as you can, and I'll go 1 over. See, that's 1 over. And then again, I count 12, and you get the idea. And you just keep going, and that's what it basically looks like. Okay, you got to be careful with these, because if you drop them, they break right in half. This is one that's broke in half, and this is the center coil, and it went right there. As you can see, it went right there, and it just broke off. So I was making the very center of these cores with these little square cores that I bought off of eBay. But I bought these, and they're just RF chokes, and they seem to work much better. I put them in the new one that you saw. These are the little round centers that you take out of these, and what you do is you just super glue them on top of each other, and then you put your first coating of your outside layer on it, and you can build it as long as you want. And that's what I'm going to do now. I'm going to rebuild this particular unit here. Okay, I'm starting to build the coil. This is the very bottom piece. This is a section out of a flyback transformer, out of the center section of a flyback transformer on an old TV. I use this grinding wheel to cut this groove around it so it can fit into the base plate. And this piece fits in here like that, and then I cut that bottom piece off. But anyway, you put this on a magnet, and then you take some super glue like such, and you put a drop in the center. You put a drop on the bottom of these little coils. You try to center it up as best you can. The magnet will pull it down, and then you just get it centered the best you can. And it doesn't have to be perfect, because you're going to build stuff around it. Then you take some accelerator, a couple squirts on it, You let that dry for about a minute or so, and you can keep building it up as high as you want. Okay, so the next step is you mix up some epoxy. Now I use Gorilla Glue. It's Quickset 5. It really doesn't matter what you use, but I find that the actual Gorilla Glue brand seems to work the best. So, and I'm not selling the product, I'm just recommending it. So what you do is you mix it up, make sure you mix it up good. You can't be really sparing on that. And then, what I do, I should have got my spoon. Where's my spoon? There it is. Okay, then you get a spoon. Now this is iron oxide. It's just a really fine iron powder. And then what you do is you take a little bit of it, you mix it in there. Try not to be sloppy like me, but you mix some in. I usually mix in about that much. And then you stir it up good. It takes a while to stir it up. So once it starts forming a circle, then you can move all the surrounding powder into it, like so. Now the reason why I do this, instead of making it a solid ferrite core, like you can stack round ferrites on top of each other, but you know, it doesn't work. I've tried it. I've tried it in many different ways with different types of cores and different type of frequencies on the cores, and you can't get one that works. What seems to work the best is you have a small center like this, and that allows the magnetic flux to come through. And this mixture here, it basically does the same thing, but it doesn't allow as much flux through. So then you put a good coating on the outside, like so. Now, I usually try to turn it around so it doesn't drip down like that did. But you put a generous mixture on it, like so. Try not to waste too much of the stuff. And then what you do, this is very important, you try to even up the mixture going up. But now this takes about 7 minutes for it to set. So what you have to do is you kind of have to make it even as you're turning, like so. You can't get it perfect. Don't try to get it perfect. I used to try to get it perfect, but it doesn't. In the end results doesn't matter. Okay, now what you have to do, once you've got it, then you have to continually turn it. So what I do is I just go like this and keep turning it, and that helps to make it round. Okay, I won't bore you with 10 minutes of this, so I'll cut and come back. Okay, this is about after 10 minutes of drying. What it looks like. Now it's a little wavy and it's not perfectly straight. If you look down the center, it's not perfectly straight, but it works good. It doesn't make really any difference at all how straight it is. But the next step is the most important, and I find this makes it or breaks it. This is what makes it work, or it will not work if you don't do it. And that's this mixture here that I put on next. Now this is a combination of the regular metal oxide or iron oxide powder, and it has a little bit of activated charcoal in it. It has a regular graphite in it, and it has graphene, fine graphene powder that I have ground up. So you mix that up. Now, I think this is just my own theory. I don't know if this is actually true, so don't hold me to it. But I think what this does is it varies the magnetic flux that's inside the core. So you get a really fast flux going up through the center core because it's standard and it's very dense. But because this is not because of the epoxy that's in it, it's not as dense, the actual core. But this here only has 1/3 of the metal oxide in it, or iron oxide in it. But it has the rest of activated charcoal, graphite, and graphene. So then you put the next coating on, like so. Now it doesn't matter really, as long as you got it covered fully. Now I tried skipping this procedure to see what would be the difference, and it just flat didn't work. I couldn't get any results out of it that I was looking for. So this is kind of an important step of building these cores. Now these cores don't take very long to build, maybe a couple hours. Now you do have to let them dry overnight, because you can't put the Teflon tape on it and start winding them until you let them dry. But now you try to make it as even as you can, so it's an even. I have a tendency to taper my ends off at the corner, but I cut it square so it's pretty well even all the way up. But it doesn't hurt it to have a taper at all. In fact, I think it works better sometimes if you have a little taper. Okay, that's what it looks like. Now I have to twist it like this for about 10 minutes. So I'll get back with you and show you what it looks like. These are some of the cores that I have built, and also I'm going to include pictures of some of the cores I have yet to build. So these are plans for some future coils that I'm going to try to attempt to build and see how they work. And so enjoy the pictures. There's a few pictures here, and then I'll get back with the instructions on how to keep building the cores. Alright, I've got that layer put on. This is what it looks like. It's real shiny black. Like I say, again, it's not perfectly straight, but it will do nicely. It has the first center cores on it, glued together with super glue. And it has a winding of regular iron oxide powder mixed with super glue. And then it has a layer of this special concoction that I came up with. And next you go back to a layer of another metal oxide on it until you get it to the thickness that you want. Now I tried building them thinner, like this one, and I've tried building them really thick, like this one. This is a different core, but I'm just showing you for the size. But I find that the best size for this is about 3/4 of an inch in diameter. That works very well. Now, this one over here that I test, it's just a little over 1/2 inch thick. Maybe a little bit bigger. So it's probably about 5/8. Okay, that's the end of this particular video. I hope you enjoyed it, and I hope that my explanations were adequate, so you can try to build one of these for yourself and test it out and see how it works. So in the next video, I'm going to show you how well these things work. I'm going to hook them up and show you the latest version, and then hopefully that'll be the end of this series. I want to get to work on my next project. So we'll see you in the next video. Thanks for watching, and if you like these videos, please push the like and please subscribe. Thank you again for watching.